Here are 7 of the most important postulates you will need to know to do proofs that involve planes, lines, and points. So a postulate is basically just a rule in geometry or any type of math that's just so obvious that it doesn't need to be proven. For example, something like 1 plus 1 equals 2, you could call that a postulate because it's pretty obvious. We all know that 1 plus 1 is 2. But no one's written out an entire proof of 1 plus 1. Actually, I think someone has done that before. But yeah, probably nothing that I say in this entire video is going to surprise you. All of these are going to seem like really obvious things, but you need to know the names of these obvious things because in a proof, you have to write everything down, even if it's obvious. So here's the first one that we'll be talking about, which is the 2-point postulate. It says that through any 2 points, there exists exactly one line. So here are 2 points. And all it says is that if you have 2 points, there is always going to be one line between them. It is impossible to have 2 points that you can't draw a line between. You can always draw a line between 2 points, but you can't ever draw 2 different lines between 2 points. You can't, once you draw one, there's no other line you could draw between them. The second important postulate is the line point postulate, which says that a line contains at least 2 points. So you cannot have a line that only has 1 point. That's not possible because you have to have another point somewhere to tell you what direction the line is going. But once you have a second point, now you have a line that can only be in one direction. And notice how it says at least, because you could have more than 2 points. You could have a point C and a point D and a point E. You can have as many points as you want, but you have to have at least 2. The third postulate that you need to know is the line intersection postulate. That says if 2 lines intersect, then their intersection is exactly 1 point. So let's say that you have a line here and you have another line here. It says that their intersection, or where they cross, is exactly 1 point. There are not 2 points here, or 3 points, or 0 points. There is exactly 1 point where the lines cross. So for example, you can't say, oh, this is one line, and then this is my second line. See, it crosses at 2 points because this is not a line. It's not called a line in geometry unless it's a straight line. So this little curved line, that's not a line. So we're done talking about postulates related to lines. Let's now talk about postulates related to planes. And remember that planes are just like a 2-dimensional surface. So think like a wall or a floor, but like they go on infinitely. So the 3-point postulate says that through any 3 non-collinear points, there exists exactly one plane. So what this is saying is if you have 3 points, so one here, and one here, if you have these 3 points, then you can have exactly one 2-dimensional shape that contains all 3 of these. Now, I know this seems kind of confusing because you're like, well, wait, I can draw another 2-dimensional shape. Like, what about this one? That one contains all 3 as well. But remember that planes go infinitely in all directions. So this plane is going infinitely this way, and it's going infinitely this way, and infinitely in all directions. The only way that a point could not be on this plane is if in the 3rd dimension, it was like above or below this plane. Like, just envision this as 3D. It's really hard to show on a whiteboard. Now, what does the word non-collinear mean? Well, this basically just means not on the same line, not linear. Here's the problem. If you have 3 points that are all on the same line, then this is technically not true. There is not exactly one plane. You can actually have infinite planes with these 3 points if they're on the same line. This is really hard to show on a 2-dimensional whiteboard, but I just want you to envision a straight line. All right. So just imagine a straight line. Then I want you to imagine having like a piece of paper that contains this line, this straight line. Well, you could have a piece of paper like this, right? This piece of paper contains the entire line. But you could also have a piece of paper that's kind of like tilted like this, and that still contains the whole line. Or you could have a piece of paper like this that still contains it, or like this. So there's more than one plane that you could have with a straight line, which is why we have to have the word non-collinear. The points have to not be on the same line for this to be true. Here's another really similar postulate. It says a plane contains at least 3 non-collinear points. That's the plane point postulate. This is basically exactly the same as the last one, but the other way around. So it says that if you have a plane, if we have, our piece of paper, then there has to be at least 3 points not on the same line on this plane. And it says at least. You could have more than that, but you cannot have a plane with just 2 points because that would just make a line. And of course, you could have a million planes on that line. Here's one that actually involves planes and lines, which is creatively named the plane line postulate. It says if 2 points lie in a plane, then the line containing them lies in the plane. So the plane line postulate says that if you have 2 points on a plane, they're both on the plane, then if you were to draw a line between them, then this line would also be on the plane. And finally, we have the plane intersection postulate. It says if 2 planes intersect, then their intersection is a line. So for this, we're going to need 2 planes. So I want you to imagine 2 pieces of paper. So here's my terrible attempt at trying to make this look 3D, right? We've got a piece of paper, and then we've got like another piece of paper that is going through this piece of paper. The plane intersection postulate says that where these cross is a line. So right here, this is where the 2 papers meet and it makes a line. But remember that a line in geometry means that it has to go infinitely. But these planes are not just squares. These planes go infinitely as well. So this intersection is actually an infinite line. It goes infinitely up and infinitely down. So there you go. Those were the 7 most important postulates you need to know for points, lines, and planes. And now that you know all of these names, you're ready to start applying them in doing proofs. I would say that for a geometry class or maybe some other types of math classes, proofs are probably the most complicated topic. So if you want to get ready to start doing these, then this is the video that you'll want to start with. And if you have any questions about this video, go ahead and leave it in the comments and I'll be sure to answer your question. Thanks for watching.